Hi everyone. So without any delay, I'll start my presentation. Thank you for inviting me. Dr. Lokesh has already kind of presented what I am a part of what I am doing today. So I will not take much time in that part. I am focusing on groundwater. As I mentioned earlier, I have worked in groundwater contamination field and have done groundwater remediation projects in India. Groundwater is basically, India is the largest groundwater user, and we basically use approximately in rural areas 80% of the domestic usage is from groundwater, and in urban approximately 40-45%. So if the groundwater that we are using for domestic purpose is contaminated, then there is a problem, right? Health problem. And groundwater contamination is typically caused by the industrial pollution, the disposal of industrial wastewater or industrial waste, or pesticides and fertilizers from agriculture. Typical contaminants that we test in India are heavy metals, cations and anions, then volatile organic compounds, and pesticides. Now, a new classification, as Dr. Lokesh mentioned, is rocking the world, is emerging organic compounds. And in India, we are not testing for it. There is no regulation for it. Pollution control boards are thinking about it, but still it is a long way for them to reach that point where they actually publish standards for it. And even the world is basically going in that direction. So I would like to basically talk a little bit about these emerging compounds, specifically PFAS. Again, Dr. Lokesh, I'm not spending too much time on this, but basically this is present in almost every thing that you use in your daily life. And we basically have done few projects in India where there was a client requirement to test PFAS, and in India we basically don't have any lab to analyze PFAS. So we send this water to labs abroad, and luckily we did not detect these in the groundwater. You can go to the next slide. You can go to the next one. Okay. So typically when we do a groundwater investigation, we have to collect the samples and analyze it in a lab to identify the contaminants of concern, and then compare it against certain guidelines or standards that is published by the regulatory agencies. So in the photo, we can actually look at these three samples that we collected from different sites, and the first one you can see that from the color itself say that okay, this is contaminated. And the second photo and third photo, the second one is cleaner. It looks quite clean, right? And the third photo looks turbid. So from a layman's point of view, you will say that okay, third sample would be contaminated, and the second one is clean. It's the other way around. So these contaminants you can't see. You have to analyze in a proper lab, where their quality control procedures are right, then only you will get the right results. You can go to the next. So for identifying and addressing the contamination, you need to have a robust site investigation program, where you collect samples, representative samples from the groundwater, and analyzed in the lab and evaluate the results. And you need to look at these analysis results and evaluate if it is risky to human health or environment. And you basically, that is why you see all these standards that government publish. These standards are basically risk assessment criteria with which you compare your analysis results. And if the concentrations are above these risk levels, then you need to do something. So you need to strategize and you need to identify the methodology to mitigate this problem. And we call it remediation. And basically remediation, again, it's a large area where you can have hundreds of technologies for mitigating this problem. But you need to identify the right technology. So there are, you basically look at different criteria like the site, the type of contaminant, the hydrology, hydrogeology, and all these things will play a part in identifying the right strategy. And then finally, you basically need to implement it. Can we do it? So again, I'm not getting into the details of remediation, but it's basically just a process of lowering the impact to meet the standards, whether it is for drinking purpose or whether it's for the industrial use purpose. Sometimes, so you need to basically have a agreement with the stakeholders. Like one of the stakeholders, major stakeholders, is the regulator. You need to discuss with the regulators and set your remediation standards or goals. And the technology will depend on the mode of action, the place of action, the point of action. So it can be a physical, chemical, biological treatment technology. It can be an in situ or ex situ. In situ means you treat the groundwater in the ground. You don't take it out. Whereas in ex situ treatment, you actually pump the water out and treat it. So when you pump it out, you can treat the groundwater just like any water, wastewater or water treatment. You can have any technology that end. So you have a bit more flexibility in determining the technology when you are doing an ex situ treatment. And also, typically this contamination happens by a source. For example, a rupture of a tank would cause these contaminants to go into ground and contaminate the groundwater. So you have concentration, higher concentration near the source of the leak, and the contamination will move along the direction of the groundwater, and you can probably have lowest concentration at the edge of the plume. Plume is basically the extent of the contamination. So you can have different strategies for the source area, and you can have different strategy for the plume. So you detect this contamination. In India, typically, you detect the contamination only when the plume reaches somebody's well, and that guy pumps out the water and find smelly water or colored water or have health impacts. So you need to have different strategies for different source areas. So I'm coming back to PFAS. We basically, even in the world over, basically people are still finding out different technologies to deal with PFAS. And one of the most common technology is bring the water out and treat it externally. That is, we call it pump and treat. It is the most common technology all over the world. But we talk about sustainability everywhere nowadays. So from a sustainability point of view, people are also looking at the in situ technologies that you can actually do in the ground without the pumping the water out. So in India, ERM has been around for more than 25 years, and we have installed many remediation systems, but most of our systems are pump and treat. The reason why that we are doing this, because regulators are still skeptical about injecting something underground into the ground. So in Western world, this is a very in situ treatments are very common. They inject oxidants, reductants, nano iron, different chemicals into the persulfate, all these things into the groundwater to degrade these contaminants. So, can go to the next one. So, as I said, pump and treat. You pump the water out. You can treat the water with activated carbon, air stripping, reverse osmosis, oxidation. These are all chemicals that can actually, or methods that can be used for treatment of PFAS. And the next one. So this is a photo of a treatment plant that we installed many years ago, actually 10 years ago. At that time we were not treating PFAS, but when I look at this photo once again, I can see that we have reverse osmosis in there, we have activated carbon in there, which are all treatment technologies for using PFAS, for treating PFAS. So we basically have for pump and treat, we have we have a very solid our technology base in India, but we basically pump and treat is a technology which is, I would say, becoming outdated because it requires high cost, capital cost and operating cost, and also you are pumping water out and you probably would be pumping for many years to deal with this contamination. So we basically started looking into the more sustainable way of groundwater treatment. And in one site in Punjab, we got this opportunity where we worked with the Punjab Pollution Control Board, and we injected ozone into the groundwater. So this was not for PFAS. This is for organic compounds, and ozone does not really work with the PFAS. I'm bringing this technology because we need to move from the conventional ways to more sustainable ways to deal with the groundwater contamination. And in this project, we basically you can go to the next slide. We basically installed an ozone generator, and we delivered this ozone into the groundwater, and we basically got approximately 80% removal, which met the regulatory standards. And the project is almost, project is almost over in say 5 years, compared to 20-30 years of pump and treat. So this is something which we are actually talking to regulators nowadays. About a month ago we spoke to Gujarat Pollution Control Board about kind of trying to identify projects where we can actually implement in situ groundwater remediation systems. So go to the next slide. So I'm concluding my presentation with a few thoughts. As Dr. Logesh mentioned, for addressing these emerging contaminants, we need to have a really good laboratory facilities in India. And we have labs, regulatory agencies have labs, universities have labs, there are private labs, multinational private labs in India. But from a groundwater contamination point of view, these labs are not, they are not doing it from a commercial point of view. They are not dedicated for only this groundwater analysis. So from a cost point of view, they are actually more expensive than sending these samples to UK or Singapore. So we need our laboratory setup, or the way we do things in our lab should improve. There should be emerging technologies, for example, in situ technologies, pollution control board. We need to basically work with the pollution control boards and other stakeholders to basically promote these emerging technologies. And the biggest thing is the regulatory driver. So nothing happens in a pollution point of view. Nothing happens if regulator is not interested. So right now, Central Pollution Control Board in 2016 has published a guidelines on contaminated site management, and 2020 they actually put another guidelines And so pollution control boards are also getting up to speed on this groundwater contamination issues, and in near future they will be bringing out some standards. Currently we are using groundwater drinking water standards as a criteria for determining the remediation goals, whereas a risk assessment type of criteria should be in place, so that we basically don't need to treat these water to the drinking water level if not necessary. So regulatory drivers are probably the most important thing, and I hope, I don't know whether if there are any regulators in this audience, but definitely we have been talking to the regulators about it. That's it. Thank you very much.